Okay, hi everyone, welcome back to the Comptia Security Plus course, Cloud Computing. Cloud computing can be defined as a way of offering on-demand services that extend the capability of a person's computer or an organization's network. These might be free services such as a personal browser-based email from various providers, or they could be offered on a pay-per-use basis such as services that offer data access, data storage infrastructure and online gaming. A network connection of some sort is required to make the connection to the cloud and gain access to the services in real time. Some of the benefits to an organization using cloud-based services include lower cost, less administration, maintenance, more reliability, increased scalability, and possible increased performance. A basic example of a cloud-based service would be browser-based email. A small business with few employees definitely needs email, but it can't afford the cost of an email server and perhaps does not want to have its own hosted domain and the costs and work that go along with that. By connecting to a free web browser-based service, the small business can obtain near unlimited email, contacts and calendar solutions. But there is no administrative control and some security concerns, which we discuss in just a little bit. Cloud computing services are generally broken down into several categories of services. Software as a service, SaaS, the most commonly used and recognized of the three categories. SaaS is when user access applications over the internet that are provided by a third party. The applications need to be installed on the local computer. In many cases, these applications run within a web browser. In other cases, the user connects with screen sharing programs or remote desktop programs. A common example of this is webmail. Infrastructure as a service, IaaS, a service that offers computer networking, storage, load balancing, routing, and VM hosting. More and more organizations are seeing the benefits of offloading some of their networking infrastructure to the cloud. Platform as a service, PaaS, a service that provides various software solutions to organizations, especially the ability to develop applications in a virtual environment without the cost of administration of a physical platform. PaaS is used for easy to configure operating systems and on-demand computing. Often this utilizes IaaS as well for an underlying infrastructure to the platform. Cloud-based virtual desktop environments, VDEs, and virtual desktop infrastructure. VDIs are often considered to be part of the service but can be part of IaaS as well. Security as a service, SECaaS, a service where a large service provider integrates its security services into the company customer's existing infrastructure. The concept is that the service provider can provide the security more efficiently and more cost effectively than the company can, especially if it has a limited IT staff or budget. The Cloud Security Alliance CSA defines various categories to help businesses implement and understand SECaaS, including encryption, data loss prevention, DLP, continuous monitoring, business continuity and disaster recovery, BCDR, vulnerability scanning and much more. A cloud service provider, CSP, might offer one or more of these services. Between 2005 and 2010, cloud services were slow to be adopted by organizations. One of the reasons for this is the inherent security issues that present themselves when organizations relegate its software platforms, especially infrastructure, to CSP. After 2010, however, implementation of cloud services has grown dramatically, with most companies either already running cloud services or in the planning stages, similar to the CSP in the managed services provider, MSP, which can deliver network, application, system and management services using a pay-as-you-go model. There are different types of clouds used by organizations: public, private, hybrid and community. Let's discuss each briefly. Public cloud. When a service provider offers applications and storage space to the general public over the internet, a couple of examples of this include free web-based email services, pay-as-you-go, business class services. The main benefits of this include low or zero cost and scalability. Providers of cloud space include Google, Rackspace and Amazon. Private cloud, designed for a particular organization in mind, the security administrator has more control over the data and infrastructure. A limited number of people have access to the cloud and they are usually located behind a firewall or of some sort. In order to gain access to the private cloud, resources might be provided by a third party or could come from the security administrator's server room or data center. Hybrid cloud, a mixture of public and private clouds. Dedicated servers located within an organization and cloud servers from a third party are used together to form the collective network. In these hybrid scenarios, confidential data is usually kept in-house. Community cloud, another mix of public and private, but one where multiple organizations can share the public portion. Community clouds appeal to organizations that usually have a common form of computing and storing of data. The type of cloud an organization uses will be dictated by its budget, the level of security it requires, and the amount of manpower and lack thereof it has to administer its resources. While a private cloud can be very appealing, it is often beyond the ability of an organization, forcing that organization to seek public or community-based cloud. However, it doesn't matter what type of cloud is used, resources still have to be secured by someone, and you'll have a hand in that security one way or another. Cloud security. Cloud security hinges on the level of security a security administrator retains and the types of security controls the admin implements. When an organization makes a decision to use cloud computing, probably the most important security control concern to administrators is the loss of physical control of the organization's data. A more in-depth list of cloud computing security concerns includes lack of privacy, lack of accountability, proper authentication, lack of administrative control, data sensitivity and integrity problems, data segregation issues, location of data, recovery problems, malicious insider attack, bug exploitation, lack of investigative support when there is a problem, and finally questionable long-term viability. In general, everything that you would worry about for your local network and computers. Let's also mention that cloud service providers can be abused when attackers often attempt to use providers' infrastructure to launch powerful attacks. Solutions to these issues include the following: complex passwords. Strong passwords are beyond important, they are critical, as I will mention many times in this text. Accept password schemes that include the following for general security: 10 character minimum, including at least one capital letter, one number and one special character for confidential data. 15 characters minimum, including a minimum 2 each of capital letters, numbers and special characters. When it comes to the cloud, a security administrator might just opt to use the second option for every type of cloud. The reasoning is that public clouds can be insecure. You just don't know, and private clouds will most likely house the most confidential data. To enforce a type of passwords, want users to choose a strong server-based policy is recommended. Powerful authentication methods. Passwords are all well and good, but how the person is authenticated will prove to be just as important. Multi-factor authentication can offer a certain amount of defense in depth. In this scenario, if one form of authentication is compromised, the others work as a backup. For example, in addition to a password, a person might be asked for biometric confirmation such as thumbprint or voice authorization, for an additional PIN or to swipe a card. Multi-factor authentication may or may not be hypothetically possible depending on the cloud environment being used, but if at all possible it should be considered. Strong cloud data access policies. We're taking the who, what and when it comes to public clouds especially. You should specifically define which users have access, exactly which resources they have access to, and when they are allowed to access those resources. Configure strong passwords and consider two-factor authentication. Configure policies from servers that govern the users. For example, user group policy objects on a Windows server, domain controller, audit any and all connected devices and apps. Consider storing different types of data with different services. Some services do better with media files, for example. Remember that cloud storage is not backup. Approach the backing up of data as a separate procedure. Encryption of individual data files, whole disk encryption, digitally signed virtual machine files. The list goes on. Perhaps the most important, a robust public key infrastructure, PKI. Standardization of programming. The way applications are planned, designed, programmed and run on the cloud should all be standardized from one platform to the next and from one programmer to the next. Most important is standardized testing in the form of input validation, fuzzing, white, grey and black box testing. Protection of all data. This includes storage area network, SANs, general cloud storage, and the handling of big data, for example, astronomical data. When data is stored in multiple locations, it's easy for some to slip through the cracks. Detailed documentation of what is stored where and how it is secured should be kept and updated periodically. As a top-notch security admin, you don't want your data to be tampered with, so implementing some cloud-based security controls can be very helpful. For example, consider the following. Deterrent controls prevent the tampering of data. Preventive controls increase the security and strength of a system that houses data. Corrective controls reduce the effects of data tampering that has occurred, and detective controls detects attacks in real time and have a defense plan that can be immediately carried out. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.